everybody. We're supposed to find a polynomial with integer coefficients. Now, I think a common adjective here also is to call it integral. Just like the calculus integral. I don't know why they don't just stick to integer. But integer can be used as a noun or an adjective, right, folks? Right, English teachers? So we're looking for a polynomial with integer integral coefficients such that this surd input gets sent to its conjugate, so to speak. Okay? Now let's see how we might go about that. And y'all, I had no idea how to, I saw a problem similar to this, and I made up this problem, but I wouldn't have had any idea how to do this without looking at their solution first. So we let the real numbers, this is just for processing and readability. Let's call this input square root of 7 plus square root of 6 r, real number r, okay? Now, it's useful to notice right now, and again, I wouldn't have noticed this at all, the reciprocal of r is obtained in this fashion, and you get the square root of 7 minus the square root of 6, which is the output we're looking for. Now, what makes this fly? Well, we multiply through by a cleverly disguised version of 1, namely the conjugate of the square root of 7 plus the square root of 6. Now, if you'll take a look at this, the only real part here that, I guess this is common knowledge for a lot of people, but I had to stop and look at it and do the calculations. If you put both of these guys in parentheses, you just have the difference of two squares, right? And so this would just be equal to 7, the square root of 7 squared is just 7. Okay, and then minus the square root of 6 squared is just 6. That's just equal to 1, right? So you see this whole thing is just equal to 1, but that leaves the square root of 7 minus the square root of 6 as our result here, okay? So we have this result for the reciprocal of our input, our polynomial input. Okay, now the natural thing to do here, and I think it's natural, this part I knew this much, go ahead and square your assignment for r, okay? And when you do that, you get all this. This is easy. This is just in the form a squared plus 2ab plus b squared. All right, folks? Okay. And so that gives 13 plus 2 root 42. Now what I do here, I leave out just a few steps, but I subtract 13 from this. So we have, and then square both sides, so you have r squared minus 13 quantity squared is equal to 168. That's exactly what you get, folks, when you square 2 root 42. This would be 4 times 42, which is 168. Now you can see this would be 169 right here. If you bring it to the other side, you get negative 1. Now you see, we got to work this 1 over r, and if we divide through by minus r, that very exact thing will happen right here. In other words, divide through by minus r, and this will become minus r cubed plus 26r equals to 1 over r, excuse me. And y'all, what did we do? We divided this object by minus r, right? Now we can, r can't be equal to 0, right? So we don't have to worry about that. But again, we divided this expression, which was obtained by our second squaring. All right, and we get minus r cubed plus 26r equals to 1 over r. But remember, 1 over r is equal to the square root of 7 minus 6, which is what we computed at the first. Okay. So guess what? Guess what our polynomial is going to be? It doesn't take a whole lot of heavy lifting. Manifestly, our p of x will change from r to x here because we've written down a solution for the polynomial p of x equals to minus x cubed, isn't that cool? Plus 26r. I think this is super cool. Now this is a solution I saw by David Altizio. He put out a practice set of problems for, I believe, either AIME or AIME. I think it was AIME. Oh, that's X. God, what am I saying? That's right, I can't talk and write at the same time. Eraser. Okay, let me erase this piece of crap right here. And let's go back up and get our pen to working. This should be x right here. Okay, so this is our polynomial. And we have shown by this work directly above that p, and I even checked it again, even though there's no doubt that that's right. P at the square root of 7 plus square root of 6. You can check it out if you want to, if you don't believe me, but this is equal to minus, or square root of 7 minus square root of 6. Now, there's no doubt this is true, y'all. That is the square root of 7, sorry. There's no doubt this is true by this construction here, all right? It's impossible for this not to be true, but some of you may still want to try to plug this in. Cube this. You would have to cube this, take its negative, and then multiply this by 26, and you will get this, okay? It's a little bit of work, but it's guaranteed to be true by this construction, okay? So that is our p of x. And I think it's what they call the minimal polynomial. It's the smallest degreed polynomial that would do this. Okay? All right. I think that does it, folks. Thanks for reviewing.